So in order to get the category of the point in this image, we need to know these three parameters: the likelihood, the transition probabilities, and posteriori probabilities. First, in order to estimate the likelihood through training, the Gaussian mixture model has to be used. To model the marginal distribution of pixels. A Gaussian mixture model is a weighted sum of G state, G component Gaussian densities, as given by this equation. Well, F is a G-dimensional continuous value data vector. And this part is the component Gaussian density. Each component density is a G variable Gaussian function. With mean vector mu I and covariance matrix sigma I. And this part, the mixture weights. This satisfies the constraint that the sum of the weights equals 1. For a sequence of n training vectors, x1 to xn, the GMM likelihood can be written as this formula, assuming independence between vectors. This equation is the nonlinear function of the parameters theta and direct maximization is not possible. However, ML parameter estimates can be obtained iteratively using expectation maximization algorithm. This algorithm is beginning with an initial model. Theta to estimate a new model theta. The new model then becomes the initial model for the next iteration, and the process is repeated until the convergence threshold is reached. Mean mu. On each EM iteration, these re-estimation formulas are used, which guarantee a monotonic increase in the model's likelihood value. the mixture weights, mean, variance, and a posteriori possibility. After the likelihood is obtained by the iteration of EM algorithm, next we need to deal with transition probability. Also, we need to obtain the P of xi slash x rho I iteratively. So first, initial model, and we get the and then we get a new model by the second iteration, and this process is repeated until converge. At each iteration, the estimate P of x through marginalization formula is shown with this. And during this iteration, we need to use belief propagation to efficiently calculate these two parameters. Belief propagation is a message passing algorithm for performing intervals on hidden Markov models. It calculates the marginal distribution for each unobserved node. And it has demonstrated empirical success in numerous applications. Variants of belief propagation algorithm exist for several types of graphic models, including Markov random field and HMM. Consider a factor and for the last parameter, posteriori probability, we just need to use belief propagation for once to calculate posteriori probability and use it by algorithm to solve the MAP problem. The detailed formula is shown. After all this, the theory part is over, and now we can train the program and do some image segmentation. The assignment in the project is to segment an image into two types of region. Specifically, in my project, it's the background and the bird. First, by introducing a series of pictures of background and birds, the program will extract feature and recognize the pattern of the backgrounds and birds. In other words, the likelihood and transition probabilities would be obtained. by iterations of training. Then by using maximum a posteriori classification. The posteriori probability can be determined, and then the image can be segmented in the assignment. At last, the result